EGI is a foundation that is providing services to scientists. We provide a huge set of services, starting from operations of federated infrastructures, like the grid system, which is provided by a set of national representatives, organization, university of different countries that provide resources, and then coordinated by EGI. Also, we provide a cloud service to the scientists, based always on resources provided independently by the different countries that participate to EGI. On top of that, we give support to the users and to different communities, and we try to define roadmaps for innovation and future technologies. So, just to give an idea where EGI is operating, well, mainly the contribution in the EGI resource network comes from European countries, but there are also other countries outside Europe joining, or as integrated external resource providers, or part of the EGI Council, like China or Brazil, Canada, etc. We have a huge set of resources. This is referred to the grid system, which is the oldest and the mostly used at the time. We run more than 1 million jobs per day, with a total of 4,000 CPU and petabytes of disk. As I said, the oldest service of EGI is the grid service, where you basically have a set of computers in parallel, you know, probably, and you submit a job to the system. What EGI is doing since 2010 is to add an advisor and provide on top of the resources of the sites both grid services and custom services, cloud services, where the user community can start their own machine with their own customized services, control them, etc. And here it's where the EGI Federated Cloud and BioWell, of course, user community fits. So what is the EGI Federated Cloud? Well, it's an aggregation of resources, cloud resources, infrastructure as a service, which comes mainly from research organizations and university, but also some private companies, and offers cloud services to scientists in many fields. We have a set of user communities, BioWell is one of them, and interfaces on top of resource providers, of course. What's the federation layer that is provided? Well, it is basically a set of open standards that are supported by all the FedCloud sites. So in the same way, you can instantiate virtual machines, you can get storage, provide images, etc. So you will see in the near presentation later terms like OCCI, CDMI. These are the all standard interfaces that the FedCloud sites provide. The idea behind is that we have an heterogeneous implementation, so there is no restriction on the type of cloud middleware which is behind. It can be openModeller, OpenStack, many names in the world on that. The important thing is that the interfaces are the standard one, so everybody can access everything that they see with the same authentication, etc. And that the resources are inside the operational infrastructure, so we expect a certain level of performances from the resources. The user communities, well, of course, is BioWell, is the one where we are working right now, and where the demo is connected. So for BioWell, we did the integration of the openModeller service, as Daniela will show. But also we are working on the integration of the BioStiff service, as it was said before in the meeting. We plan to have something to show on BioStiff probably the beginning of next month. For the other projects, as you can see, some of them are ongoing, some of them are already completed, and they cover a lot of different areas of the scientific research, like biology, linguistics, earth observation, musicology, etc. Just the last slide. Who is in the FedCloud? Well, there are more than 70 people in the task force deciding which standard to use, coordinating, etc. Coming from 40 different institutions. We have a set of technology providers that gives the software, all the background, and the resource providers, which gives the power, the computing power for the machine. We cover also a set of wide technology. As I said, we are quite technology agnostic. In this demo, we will use resources mainly from TestNet and CERCA, which are Czech Republic and Spanish organizations. And Daniel Letti is coming from the Barcelona Supercomputing Center, and it's responsible for all the technology part of the integration of openModeller. So that was my very brief presentation. I don't know if there are questions. Okay, seems there are no questions. So I would ask somebody to give the presenter to Daniele, so we can go for the demo.
Okay, hi, I'm Daniele from EGI in Barcelona. I'm here with my colleague for demoing this first version of the integration of openBio, Brazil openBio and BioWell in EGI. So just a quick description of what of our implementation and of the demo, the test that we run today. So this is, I like this slide because this expresses the requirements, let's say, that we have both in openBio and BioWell. There is the need for the user to run something which is called openModeller application for the niche modeling problem. Then so far we been using it. Before the project, we've been using one machine in Brazil managed by PIA, managed by one person, Renato, in this case, providing all the feedback on the good service. So, of course, when more than one person, just two persons has to access this service, there is the problem of how we can share these computational backend, these facilities. So it's a problem of how we can scale, in the usage of this service. So in both projects, we have been addressing this issue from different point of view, and just another question. What about not only more than one person has to access this facility, but also if one person if one scientist wants to run a complex openModeller workflow, which includes more than one model, say all the models, all the algorithms possible offered by openModeller with more than one special resolution, etc. So what about a complex request, not just a create model, let's say, talking openModeller language request. So this is also a problem of scalability. It's a problem of execution of this complex workflow. So in openBio, we address this second aspect of the problem, which in some aspect of course include also first one. Of course, if more than one person has to access the service, we are providing the facility to scale along the number of people using the service. So in openModeller we produce, thanks to collaboration with University of Valencia, PSC, and the PRIA, a new version of openModeller web service, which will be, I think, integrated also officially in the next releases of openModeller. And this version addresses the execution of complex openModeller workflows on a distributed infrastructure. In particular, here in this demo, we will, in this context of EGI, we have been addressing the execution of complex workflows with openModeller in cloud. This model that we developed in openModeller, as I said, of course, solves also the problem of BioWell, which needed a more flexible environment in order to serve the bigger community of bioscientists. So in this picture, briefly summarize two things. First thing, that our implementation of the openModeller web service is to be interoperable with both communities. Let's say the openModeller community with the need of executing complex workflows, and the BioWell community, which at the moment still runs through Taverna or the BioWell portal, what we call single request. By the way, sorry if I use word wrongs, because I'm not, of course, a bio expert, so in many cases I can do many errors when I speak. So from one side, we wanted to provide something which was compatible with the previous user communities, okay, with the previous version of the application of the software. So this upper part of the picture. On the other side, we wanted to be interoperable with different computing backend. And so with this aim, we extended the Brazil openModeller infrastructure, which here a small part is depicted here, in order to submit this ecological issue model application in the federated cloud of EGI. In particular, you will see here in this demo how, through the use of the BioWell tools, in concrete Taverna, we will be able to execute the workflow using our endpoint, the endpoints provided by openModeller. In particular, this is hosted in University of Valencia, and the request will be dispatched by the ComSuperscalar technology, which is a product of here of Patron Supercomputing Center, which is a tool that eases the execution of application in distributed environment. And also we will use the middleware, the cloud middleware we developed in a part of project, which is called VNC. So here in this picture is the openModeller architecture. Okay. Here in this picture we depict the fact that we are able in openModeller we address not only the cloud part of the execution, but also we stayed also with another test which included the use of Condor in a cluster in Brazil, and we also use other technology provided by CNR in Italy to build what we call virtual process environment. They say, just to use easy words, let's say portals, like the one that we are used to use in BioWell, but with more complex and advanced characteristics. Okay, but this central shape here is what we will demo today. the extension of an existing technology in order to serve different communities on different backends. In particular, we would use the EGI cloud, which includes the possibility to execute the application on different infrastructure, like the one explained by Salvatore in the introduction. In this case, we will use the EGI Federated Cloud. In this demo, you will see that I will use, just to show you what's happening behind in details, we will see that we will use an orchestrator service, which actually is something that decides in which of the available backends, for example, SESDA or SESNet, no, the two backends that we use in this demo, is better to execute one openModeller request. And we will use the storage service of CPU, even though you won't see this. It's just an internal detail. Let's say here in this big picture of openBio, external communities, in this case BioWell, is entered here at this point what I call legacy client. I say legacy to say something that existed before the openBio project, okay? But through this interoperability box, the two box, we are able to serve both communities.
Sorry, can you go back to the previous slide?
This one?
Yeah. The openModeller web service extended, is that exposed as a web service?
Yes.
Okay, so there is a sort of WSDL or REST.
Yes, WSDL. It's just the same WSDL of the current openModeller protocol, but we extended this to include the possibility to submit the complex workflows in openBio. So this web service, which is a re-implementation, of course, of the web service, allows to yes, Alex, yes, it's registered in the biodiversity catalog, allows to seamlessly execute from an existing openModeller command line client, for example, just to do tests, or from our portal in openBio, which includes the possibility to compose complex openModeller workflows. Okay. So actually, yes, this is our design choice. When we designed the architecture, we decided not to implement something completely new, but to extend something existing. Actually, this extended is now installed 2.0, if Renato can confirm, and will be put back in the official release of openModeller. Okay, so the next releases of openModeller will include this addition that we developed in test, let's say, in openBio.
So by an openModeller workflow, does that include? Would that handle things like the asynchronous services, so that you no longer have to sort of call create model, get the ticket, then keep on polling until?
Yes.
Okay. In which case, then could presumably the ENM workflow for BioVal could actually just figure out the specification of the openModeller workflow and then do it as a single submission?
I mean, I don't know if I understood the question, but in this demo, in this case, for example, what we did was to take an existing Taverna definition of a workflow, and we changed the endpoint in order to point to our extended implementation. So the calls to openModeller operations have been substituted with calls to our endpoint.
Okay, so you haven't looked at using any of the new capabilities that are available?
No, because to be honest, I'm not aware of them either. So
okay.
So this was just, let's say, a first proof of interoperability between the two communities in also in a completely different environment, because of course what we developed the DSC was the use of our cluster, for example. No? So let's say this was a three partners collaboration: openBio, BioBell, and EGI for the provision of the infrastructure. So what we did was to test also our implementation on the different completely external infrastructure scale. So what we did was to modify the test, in this case the workflow, to point to our endpoint, which actually allows the scalability features. Okay, just to be clear. Of course, I understand your question was something that I asked a time ago. How can a client, let's say, could leverage the existence of this catalog? So I'm a user that want to submit something. How can I know the endpoint that better serves my request and use, for example, the extended point of the other one using, for example, the catalog, if I understand your question? Because in this case is a static demo. We decided to use just our endpoint and the seed. Okay.
Thank you.
Okay. So what I will show now is let's say a typical BioBell-like execution. In this case, what we'll use are two providers. In this case, we will have, for example, Tesga and testnet here. So two providers of the EGI Federated Cloud. And this endpoint is deployed, as I said, in Valence, it's the extended endpoint, and we will make use of Taverna. I will use Taverna because the portal today had some problem, so but I will use the desktop workbench kit with the same workflow. So this request that comes from the specification in the Taverna workflow will be managed by the service, the cloud storage model web service, that will redirect this request to the cloud backends. So this service in this case also is a load balancer of the request. So with this feature, we somehow answer the first problem on my first slide: how we can manage multiple requests from multiple users, how we scale with the number of users. So this is a first answer, because imagine that here we have more than one provider. Each provider provides different capabilities in terms of computational resources. And this service, using also the addition of something developed in openBio, which is called the quality orchestrator, this service knows the load of each backend it can use, and it fetches the different requests to different providers. Here with the arrows, I try to explain that, for example, inside a single workflow, you can have here a get layers, you can have a create model, in red you can have a project model, etc. So just to let you know that each time the service is contacted, he forwards the request to a different backend managed by our home superscript here in Barcelona. Just to give you a more technical detail, in order to avoid the virtualization overhead that you may know existing in cloud, we are.
Sorry, could you go back? Where? Sorry, stop. You said that it called a different openModeller each time that the ENM service is called. But if I ask it to create a model, I then get back a ticket. If I have to talk to exactly the same openModeller.
Yes, but you're talking to the same endpoint, to this service. Okay, so this is your contact point. This is your contact person that holds the information of the ticket, as you say. Okay.
Okay, so you have a look
but internally, instead of running on the same machine, for example, as we do now, which is the one server in Brazil that can be overloaded, as you may know, this service is smart enough to use different, let's say, PCs behind, okay, like it was just one. So it's a way of aggregating resources as a big computer. Okay.
So is there some sort of hash so that if I then go and ask the openModeller whether it is finished creating the model, I am still talking to the same openModeller?
Yes, right.
Okay, fine.
Yeah, we implemented exactly the same behavior of the model, and also the extension. I mean, this extension has been made with the collaboration of Renato, so the developer of openModeller. So there was a strict collaboration in order to maintain things consistent, of course.
Thanks.
So, as I was saying, in order to, of course, you know, EGI, as Salvatore said, is a cloud infrastructure. And cloud, not everything is wonderful, is perfectly working and is efficient from some point of view. So, consider that in BioWell, the kind of execution is not so, one execution, not so computational heavy, I don't know how to explain the word in these words, is not so big from the computational point of view. We decided to configure these components here in order to use pre-deployed machines. Pre-deployed means that this service that runs on each provider is able to have a sort of pool of resources, like there were not dynamic virtual machines, but steady resources, okay, but also is able to scale to create a new machine depending on the load, okay. So here we have a load balancer which translates the request coming from for example, the postal. Then there is a number of providers providing the openModeller application with the software backend, and this is a mixture of static and dynamic provision of resources. I can give you more details maybe offline, because this is not the end of this demo. We don't have so much time, okay? But just to say that with this slide, I try to explain the fact that we managed to solve we are trying to solve the first problem, how to scale with the number of requests coming from different users and different portals, etc. Okay, so this will be the demo today, the first part of the demo. Then there is this complex, more complex, let's say, slide which models what we address in openBio. Where, you know, in our portal, it's a different approach, because the user with the openBio portal compose a complex workflow, I said before, which contains multiple models, multiple pieces, multiple algorithms, and multiple model creation, generally speaking, okay? So we have one request, which is good, okay? This complex request is managed by our superscalar component, which is able also to start this quite long computation, because you can understand that in this case the duration of the workflow is longer. It's a really bigger computation. Also take into account that this kind of submission is more appropriate also for layers which are big, so big phase model request. Okay, so our component is able to start the computation with a number of virtual machines, and is also able to scale out to another provider to request additional machines if needed. This is more something which is, let's say, nice in EGI, because from your point of view, from the user point of view, is can be less important, but from the point of view of EGI, the fact of having one application deployed on different providers, spawned on different providers, is a really important requirement. Of course, the fact of being able to parallelize somehow this execution using different resources is managed by our programming framework, again, which is ComSuperscaler. Again, if you want to know more details about ComSuperscaler, please ask me offline. I will explain. So, but just to let you know that this box here is able to parallelize the execution of this complex workflow using resources from different providers. Something that can be addressed maybe in another discussion is, of course, the shared storage issue that I think that you also very well. I mean, the part of synchronize the layers between different backends, computational backends is something that we are trying to solve, and also depends on the specific backend. Okay, but I don't want to go in. I put here just as an issue point to be discussed in another meeting, maybe. But just to say that we are addressing this problem. And later I will show briefly also a demo with this workflow, something that is already running because it's quite large. Last more than 1 hour, it's already running. I will show just a graphical screenshot to let you know what's happening. Okay. So I talked already about this the testbed. So we will use SESDA machines. So Czech Republic and Spain. And so if you don't have questions, I will pass to the demo. So as I said, we have here your familiar Taverna workbench. Again, I cannot use, we've been testing the portal these days, but just 1 hour ago, the portal had some problem. So, but from the demo point of view, it's completely the same because the specification of the workflow is exactly the same. Actually, this modified version with the openBio endpoint you can find in your portal. I uploaded some days ago this workflow, okay, in the BioWare portal. So I'm a typical user of openBio. I will start the workflow. I will use the default values. Okay, so here the workflow is starting. Okay, now something is running here. Yes. Okay. In the meantime, I can show you the other what's happening in the other demo. Waiting for Taverna to wait to something. Okay. Here. So sorry. So here I will select the algorithm. Okay. The bioclean. I will fight with Taverna. Somehow I don't know why you get heavy. Maybe now we can. I don't know why it's going to this old workflow. Okay, so I continue putting the parameters. In this, open this window to show that at some point when the execution will be ready, I will show also the layers. These layers, just for the demo simplicity, are stored locally to the computation backend. Okay, just for simplicity of the demo. Our implementation actually checks if the layer is available locally. Otherwise, it downloads it from the layer repository. Okay. So I will explain that here is the monitor of what we call orchestrator, and that will decide now which of the two backends that we configure, SESDA Spain or SESDA in Czech Republic, will be best to be used to submit the user operation. based on this information, as you can see here, is happening something. So here, this component, which is an openModeller component, has information about the two providers. Each provider knows that each provider has an openModeller platform that supports the BioClean algorithm, okay, and decide which of these two is able to execute the operation. As you can see in this window, so we don't have any graphical interface for the monitor, but it's actually our internal details. As you can see here, so the openModeller submission arrived at Sesga in Spain, because Sesga was decided as the provider here. So this single operation is being executed on this on a virtual machine available at this provider. Okay. So as long as the execution will run, you will see that I will of course other interaction with the portal or with the Taverna workbench. Okay. So in this way, actually this is the correct report. So all these different requests, different parts of the request which needs an openModeller submission will be managed by our endpoint, the extended openModeller endpoint, and will be redirected to one of the providers. Okay, probably now this operation has been executed on this machine. Later there will be the result of this operation, and maybe the load balancer will decide to go to another provider, okay, or maybe to the same. I mean, these are details of handling of managing the resources. It is not important to you. This was just to show you that actually we are able to balance the execution of these workflows on different resources in EGI. Okay. Just let me go back to something I was showing before. This is another workflow, the big one that we executed before. So the scenario 2. This actually this is a part that's already been executing of the workflow. All these are operations managed by the superscalar programming framework that is parallelizing the execution of these operations here. Here in this upper part, you can see that this execution started at this machine, okay, which is hosted at Czech in Czech Republic, so say the main computation. But there are two more machines requested to another provider, okay, in EGI. So superscalar dynamically requested this machine to the providers and executed some tasks here. So you can see that there is one machine that is executing 4 tasks. Actually, depending on the color, we can say what's happening. For example, this is an operation of collecting the results. There is maybe some project here somewhere. I don't know. I mean, some of these, yes, it's a project. You can see here these pink operations, okay, like the number 9. I mean, these numbers are internal numbers. It's been executed on a machine here, okay, in parallel to other operations. So actually, valuable kind of executions are, okay, included in this kind of run, right? Instead of having something parallel, in your case, we have sequential calls to the web service, okay? But from the management of the infrastructure is managed at the same way. There is a load balancer, there is a scheduler, okay, something that takes into account your request and dispatches this request to the EGI Cloud Federation. So in case of having this screenshot now answers the second question on my second slide. What about multiple users instantiating big multi-modular requests? So this is the answer. The openModeller middleware is able to take into account this complex request and dispatch this request to the extended niche modeling service to the available resources. In the meantime, here something I think is happening. I think that I was wrong selecting the layers, so maybe something is going wrong in this execution. But I don't know, maybe I'm wrong. Actually, here in this execution, we are using quite big layers. So that's why each execution is taking time. Renato can explain better which layers I use. To be honest, I'm not familiar with these terms. So going back to this, as you can see here is your own portal or client, the workbench, the taverna. This can be completely substituted by the portal, and you are using our the openModeller technology using. So this is openModeller. Imagine this is openModeller, and this is EGI. So here in this screen you can see the three actors of this collaboration. BioWare, openModeller working behind the scene, and EGI providing the resources that are managed dynamically by our framework. So these demos are running now. So if you have some questions, as you can see here now that the first operation is finished. Okay, so Taverna here will continue. I think the nobody's using always this loop. Is continuing the execution of the workflow, and as long as the operation will finish, the workflow will be, as you can see here, the workflow will be covered, okay, and more requests will come to the, okay, here for example, the test results. More requests will come to the openModeller endpoint that will redirect, let's say, will elaborate. It's not just a redirection, it's because there is an elaboration of this request and will forward the execution to the best cloud infrastructure and the execution time. Now we have another request to the endpoint. Okay, again, the load balancer decided, the endpoint decided to use again the same provider. Okay, it thinks that it's okay, so the request is coming here. In starting the workflow, I think the more interesting part, even though it's not so practically appealing, is this part, the fact that actually there is a computational backend that is addressing your issues of having more resources, because this was the first problem. I remember at the beginning when the problem was presented with EGI. We need to have more actually resources to execute openModeller applications. So I think that this collaboration between the two projects managed to address the issue. And of course, we are in openModeller, we are tuning these components, these tools, okay, and so we will continue supporting the use case, which I think is a shared use case, okay, because we have completely shared requirements. Even though openModeller, maybe if I can answer a possible question about the future, openModeller is ending now in September, but there is another project which also is a collaboration with Brazil in Europe, which will continue supporting these tools. We will, if someone of you who was in Rome Even I had a talk where I explained the work here in BSc in this project. So in October there will be the kickoff of a new collaboration that will include 2 use cases that we make use of the ecological niche modeling services provided by openModeller. So there is a continuity, okay, in the provision of the technology. Okay. And also, I know that there was a request to support with this same infrastructure BioSteve. I already talked with, I don't remember who Salvatore, with Nuno about this, and we are available also to support extensions, okay, support more use cases in the same way, okay. So please, if you have questions.
It's about the software openBio is already within the different computing facility, or is kept somewhere else, and then injected in the computing node? And if yes, where?
Okay, so there are different parts of the components here. The endpoint, of course, is deployed in one machine, which now is hosted in Valencia, and is a completely new outcome of the openBio project. So it's outside the cloud in this case. Of course, it can be deployed wherever. What is available already in the machine are of course, better in the cloud are the virtual images of the use case. If you go to the EGI marketplace, some several providers have deployed the use case image, okay, and you can discover these providers through the information system or the same EGI marketplace. Okay. And in each of these images, there is the implementation, there is the openModeller software, the binary, let's say, and the implementation of superscalar workflow on top of openModeller. So the machines are plain machines plus some libraries, the openModeller and some superscalar libraries. So I think I answered your question.
Yes, indeed, yes.
So there is another question, sorry, from Francisco in the chat about how, I don't know if you can see, how we measure the workload of the virtual machine. This is managed by a monitoring tool in openBio that monitors the load of the backends. Okay, so we know exactly each provider how many machines is providing of the one that can be used, the pool that can be used, so we know the actual usage of the infrastructure, so we can dispatch the different requests to the available nodes depending on scheduling policies, let's say. There was another question before in the background.
Yeah, I wanted to ask, what is your expectation in terms of having the service ready for production?
We are testing also with you the final. We have to align the endpoint to be 100% compatible with the model test unit test. And I mean, we have to deliver the final version of all the components at the end of September. And from the, let's say, the computational backend, so what is running here, no? Let's say in the virtual machine, and also the maybe going back to the slides, okay? Here, no? This part is being aligned now, and it has to be finished in September. This part is already available because this actually is the execution service from superscalar framework, the execution service, and all the execution related parts are already available since the project. So we extended a bit to support the use cases, but the virtual image that I said before is available in EGI since the first demo in March in Manchester in EGI, in the user forum, community forum. So we think that we have to align the implementation of the service, okay, and I think this can be used in production. Of course, we need, I think, also the support now from the case from the BioWare community. We will do our test with openBio using our portal, but maybe it's good that some point BioWare will start to use the endpoint in order to validate the implementation completely.
Thanks.
The place where you say the software is somewhere on the bottom of this website, where all the applications are exposed.
Okay, so let me. So there are different pieces of software. Okay, so there is the endpoint itself that is available, will be available at the end of openBio project from the openBio repository. Okay, then there is the constant execution service, which is deployed in the each provider. Okay, which is a component that can be already downloaded from our webpage, the Partner Supercomputing Center webpage or from Superscala, and is also linked, I think, in the openBio portal. All the information is available in the openBio portal, by the way. Okay, so the implementation of the use case in terms of virtual machines to be deployed are in the EGI marketplace of the Federated Cloud. Okay, let me check the link, but you have to have access to this website. Okay, you need a certificate of course. If you access the infrastructure, you will have access also to the marketplace. As you can see here, for example, look, there is EGI Cons in Juli. There is EGI Cons, which is the virtual machine deployed in testnet that we are using right now. Okay, so when we ask for a new resources in testnet, this virtual machine will be, this virtual image will be used. Okay, so there are a bunch of providers that are providing, look, the supporting the use case. Okay.
Okay.
Of course, and you already have the client part, of course, the BioWare portal of Taverna already supports the endpoint, of course. So, in terms of, if your question is more about the administration, for the administrator point of view, what you need is to know about these 3 boxes, actually 2 boxes here, okay? Where the endpoint is, and eventually which provider is supporting the execution to the deployment of this execution service, which is a Tomcat. Sorry to use technical words, is a Tomcat package deployable. It's a VMC product. I don't know, sorry if I have to run a bit because the time was not so long. This was decided as a first a call, as a first telco to show you these results. Of course, we are available to explain offline, or we can organize another demo to explain, for example, more detail, the technical details, okay? And if you want more details about the technology, come is here, and all the information about this is available in the Brazil openBio page. Okay. If someone is interested to start using the tools, of course, we have to talk, to coordinate, and Of course, from the sustainability, from the production point of view, I already said that we will continue supporting this use case, this technology at least in the next 2 years. Okay, we will extend this use case in another project, and so we are not going away. So whenever we are here to support the deployment of the use case, to extend it, etc.
Okay, thank you very much. I stop the demo now.